All right, let's go ahead and jump into example D here. All right, we're, I think, asked to do similar things where we're analyzing critical values of the following functions and then tell where each one is increasing and decreasing. All right, and in letter A, hopefully this one doesn't trip us up too much, but we're given a function that equals x to the third minus 2x minus cosine of x. Now, we can graph this as is in your graphing calculator. But because I'm going to do things like increasing and decreasing and analyzing critical points, I know that that's a first derivative levels analysis. So what I'm going to do is I'm going to take the derivative of f prime first. And so f prime of x is going to be 3x to the second minus 2. And derivative of negative cosine is positive sine of x. And, you know, from our work up above, I know that the critical points are where this function's derivative, where f's derivative, is going to equal 0 or be undefined. And even though this one has a sine of x in it, all right, a sine of x is a continuous function, it'll never be undefined, but I think it will be 0. So let's go ahead and set it up. Set it equal to 0. And I think that this is a problem where we would normally start to think about doing some factoring and trying to solve. But with that sine of x, it becomes a little bit tricky. And so I think what we want to take a look at is now plugging 3x to the second minus 2 plus sine of x into our function, okay? Or into our graphing calculator. And so that's what's over here on the right, okay? That's what this graph is. I went ahead and plugged that into Desmos to be able to take a peek at what that is. And so the values where this function is 0 are going to occur where they cross the x-axis, right? That's where the output of 0. So I think that the x values that'll be 0 for this are negative, 0.97? And that might be rounded. Remember, we don't want to round too soon, but I'm working with a Desmos online calculator instead of my normal TI-84 or 89. So, and then the other one is what, 0.677? And even though those are decimals, those are perfectly fine to work with. Let's go ahead and set up our sign chart to kind of help us here, right? Now negative 0.97 and 0.677 for f prime of x. And because we've got a graphing calculator and because we can see the what that looks like, I think we can take a peek at doing the sections here without actually plugging things into the actual equation. Right, we've got the graph. Over here, I think, from negative infinity all the way down to that first critical value at negative 0.97, the derivatives above the x-axis, which means that the graph, with the derivative being above the x-axis, that means a positive output, right? It's above the x-axis. Between negative 0.97 and 0.667, right? The first derivative's graph is below the x-axis, so I think that means that the output is negative. And then on the last little section over here, oh, you get the idea, right? Starting at 0.677, moving on to infinity, we're back above the x-axis again. So hopefully that's going to be able to help us be good at seeing what's happening with our derivative there. All right, so let's go ahead and write some stuff here, right? I can say that our f of x is going to be increasing, right? F of x is increasing because what? F prime of x is positive or greater than 0, and that's going to be from negative infinity to negative 0.97, right? That's this section over here. But then we also go from 0.677 out to infinity. And that's our increasing sections, right? Because the first derivative is positive. All right, we will also have a decreasing f of x because the first derivative is less than 0, right? Or negative. And that, I think, occurs in our middle section here. And that's going from what, negative 0.97 to 0.677. And I think, well, the parentheses are fine. If you put brackets around everything but the infinity and negative infinity, I think you're good here too. Okay, both are I think are acceptable. I think they might actually be going to brackets at some point, but you never know. All right, so there's increasing and decreasing. Let's see if we can go ahead and write a statement here about local max and local min. And I'm interested in those critical values and whether they're changing coming in or changing going out. So I see positive first derivative means increasing to negative first derivative means decreasing. Boy, that sure looks like a local max to me. So because f prime of negative 0.97 is 0 and f prime of x changes from positive to negative at that x equals negative 0.97. What do we have? Local max? Local max. I think I squeezed it in there. All right, the other one I think that I'm interested in is 0.66. Negative first derivative means decreasing f of x. A decreasing f of x to an increasing f of x means that we have a local min. So I'm gonna write that first actually. Local min at 0.66 or 0.677. And it's because f prime of 0.677 equals 0. And f prime of x changes from, in this case, negative to positive at x equals 0.677. All right? And I didn't have a ton of room there. I kind of tried to squeeze it in. If you needed a little more space, that's great. All right, let's try one more example here. Let's see if we can squeeze this one in real quick. And then you'll get to spend some time working on the rest of those. All right, again, we're doing intervals of increasing and decreasing and evaluating critical values. So that means first derivative. Now, first derivative of this function is a quotient, right? X over x squared plus 1, or x divided by x squared plus 1. That means we need a quotient rule to help us. So g prime of x here is going to be low, x squared plus 1, d high, which is 1, minus high function x, d low, minus 2x, all of x squared plus 1, all squared. Now, we don't have a calculator active on this one, so let's go ahead and do some simplification. I think my numerator is going to be, that first term is x squared plus 1. And then I think the second one is minus 2x squared. All over, I'm going to keep that ugly denominator the way it is. And then I see x squared minus x squared, or 2x squared. I think I'm left with 1 minus x squared in the numerator over x squared plus 1 all squared in the denominator. Now, critical values will happen when we have 0 or undefined first derivative. So I want to take both the numerator and the denominator and set it equal to 0. And so that's what I'll do over here. I'll take the denominator first. And I guess I'll square root both sides first, right? So square root of 0 is just 0. And if I subtract 1, x squared equaling negative 1, that'll never happen, right? We can imagine how that could happen, but we'll save that for another day. All right, the other one is 1 minus x squared equals 0. the numerator. If we add x to the second power over to the right hand side and then take the square root, I think we get critical values of plus or minus 1. So let's take a peek at that, right? Let's go ahead and set up our g prime of x sign chart for this. And I got -1 and I got +1 there, right? And let's see, the version maybe I like the best is maybe right here. Okay, I think I can see, especially with that, maybe I'll change colors, that denominator. Isn't that denominator always going to be positive, right? If I take whatever x is and square it, it's positive. And then add 1, it'll be positive. And then if I turn around and square that, it'll be positive. So as I'm going through this, I know that this denominator of g prime is always going to be a positive number. So hopefully that'll help me out here as I'm trying to figure out my signs. All right, let's think about plugging in a -3, -4. If I plug in a -3, -4 here, squaring it will be a positive, right? +9, +16. And 1 minus that will be negative. So negative divided by that positive will be negative. All right. I think I'm just going to jump over here to the right side. If I plug in a x equals +3, let's say, now I'm going to end up with 1 minus 9 again in the numerator. Do you see getting that negative value again for numbers greater than 1? Divided by the positive number. I think I'm getting negative over here as well. Okay? And again, we don't really care about what the actual output is at any of those values. We just want to try and find our sign. And then let's do the last one, x equals 0. If I plug 0 in, 1 minus 0, I think that's positive, right? That's going to be 1 in the numerator divided by a positive in the denominator. So positive divided by positive is positive. All right, I think I got just enough time here maybe to try and scribble out some of these increasing, decreasing, so on and so forth. I'm just going to move over here. All right, this is what, g of x. So g of x is increasing, right, because g prime of x is positive. And that's going to happen from, looks like just -1 to 1, right? Just this little middle section here where that's positive. And then g of x will be decreasing because g prime of x, the derivative of g, whew, words are hard today, are less than 0. So that's going to be what, -infinity to -1. And then again from what, 1 to infinity. Right? Those are the two sections right here and right there. Okay, don't scrimp on the descriptions there, right? Make sure that we're being very accurate in how we represent those. All right? All right, last little section here. If I have a negative first derivative decreasing g, right? Positive first derivative of g increasing g. You see a local min? So a local min at x equals -1. And it's because g prime of -1 equals 0. And g prime of x changes from positive, or excuse me, from negative to positive there, right? At x equals -1. All right, one more critical value to take a peek at. Positive g prime, so increasing g. Negative g prime, so decreasing g. That looks like a local max to me. So a local max at x equals +1. Oh, I forgot my negative up here. And it's because g prime of 1 equals 0. And g prime of x, hopefully this is becoming repetitive, changes, in this case from positive to negative, at x equals 1. All right, just running out of time here, so go ahead and work on the next few questions, 4, 5, 6.